The broadcast is now starting. All attendees are in listen-only mode.
Hi everyone, my name is Paul Bemis and I'm going to be starting today on the second day of discussion about modeling raised floor data centers. So just in case a few of you weren't here on the first day, on Monday, 9, I realized Monday was a holiday for many. In order to interact with me and ask questions, there's two ways to do it. One of them is to use the chat window and just type in a question, and I have that chat window open on my other display, and I will try to answer your questions as we go. That's probably the easiest way to do it. The other thing that that you could do would be to put your hand up, and I will try to open your mic, and you can ask. We can try to talk during the webinar. That usually works. It's a function of what kind of headset or microphone. If you're using speaker and mic on your laptop or whatever, that gets a little tough. Either one will work. I like to make these interactive, so please ask questions, and it makes it more interesting for me as well as you. Okay, so I'm going to start off again today with a few PowerPoint slides, and then I'm going to pop over to the CoolSim modeler. I have put a bunch of models on the shared drive for you. You should be able to download them. They're both examples of full models, full CoolSim models. Those are .csp files. That stands for CoolSim package. The others I have put there are CSO files. Those are object files. From within the model, you do an import, file import. I'll show you how to do that. Today's outline, we're going to be talking a lot about IT racks. Now, there's many different ways you can model a rack, and I'm going to be showing you them. Also PDUs, what is a PDU, and how do you use it? I'm going to talk about cable cutouts a little bit, perforated floor tiles, and floor leakage. If I'm forgetting any of this stuff, please remind me. There's a lot to cover. We're going to try to do it in an hour. It's ambitious. On Monday, it took 90 minutes to get through just laying out rooms. But I'll be here as long as you want. I'm open until 10:30 at least, and we'll try to take all your questions. So let's begin. Modeling racks. Now, there's a rack editor. When you drag the rack into the room, you'll see this editor. In CoolSim, we tend to work in terms of rack rows. A rack row is defined as a row of racks with the same dimension. And that's a fairly good assumption. Specifically, the dimension of a rack doesn't really have that big an influence on the simulation itself within a certain range. In other words, the difference between a 42U rack and a 48U rack is fairly insignificant. It's the heat load that we're worried about. And so assuming that your racks are the same size, unless they're off by a foot or two or 6 inches or so, is a fairly good assumption. The defaults we use are 7-foot racks. By the way, this can be in U's as well. So it's a 48U, 7-foot, 3.5 deep, 2-foot wide rack. That's kind of the default. You can change that to whatever you want, but that's the default. And we have different types. You can have a front to rear, front to top, and a front to top to rear. That's just changing the outlet, really. Front to rear is the most common. I don't really use front to top much, and I don't use front to top to rear much at all. Just really front to rear is what you see. And you can change orientation. You can rotate the rack. You can also change the flow direction. You can also, as you see down here in the lower right-hand corner, you can put a vertical exhaust duct on it. Now, I'll show you when we get into the GUI that in order to do that, you have to have the right type. It has to be a front to top. And then this will light up, and then you can put this on. But there are some assumptions about this that we'll talk about as we start to look at the user interface and the modeler itself. All right, so now you can also get into the rack itself, and you can do watts per rack, which is sort of first level of granularity in terms of detail. You can also now get into the rack and begin to define the load within the rack itself. And we also support blanking panels and gaps, and I'll show you that. This allows you to get more granularity in the rack row itself, because the first level of detail is I'm going to assume that the average watts per rack is X, because it may be a new design and you don't know what the loads are going to be, or it may be an existing design but you don't know what the loads are. So we have to start somewhere with assumptions. Average watts per rack is not a bad assumption for first level of sort of granularity, first level of detail, but it does assume that the load is evenly distributed across the rack, and that's not always the case. So we give you this next level of detail, and this allows you to define where the load is in the rack. And here's an example of what that user interface looks like. Again, I'll bring this up for you in a moment, but this is what it looks like. It is a spreadsheet style of interface where each one of the slots is a U. So in this case, the user has highlighted 6 slots. You can see the 6 right there. They've said you right mouse click it, a little editor comes up, and you can define, in this case, the user has put in 3 kilowatts. They've got an expected temperature rise of 18 degrees. That's a little low. It's usually 20. Sometimes it's a little higher. And that affects the airflow. The flow rate right here is calculated based on the delta T. And so the user has defined that they're going to have, it's going to be 3 kW in the rack, but it's located right here. We have found this to be the most effective way to load these racks. Now, we did in earlier versions of CoolSim have library items, but we found that you spent more time in the library system trying to find your particular model, and then only to put it in the rack and realize you have to derate it anyway or change its value because the configuration of the server is different than what was assumed in the library. This makes for very big libraries and lots of fooling around with libraries, and we found that it just wasn't very effective. This is a little more effective, quicker, and you just load the racks with the proper wattage. You can get it from oftentimes there are measurement devices near the rack that you can get the loads from, or you can measure them using a current clamp on the circuits if you have to. But that's the detail within the rack. PDUs are really just bottom to top devices. I'll show you these in the modeler as well as soon as we step over to the interface. They flow from bottom to top. When they sit on a floor, like a raised floor data center, they punch a hole in the floor and pull air out of the floor. If you don't want them to do that, set them up off the floor using the Start Y feature. But you can set these up with size, you can set them up with heat, and they are bottom to top devices. Heat load. You can also use these for fans, and I'll show you how to do that. Vent tiles are fairly straightforward. We do these in rows as well. You can set these up either 2x2 or 60 by 60 centimeters if it's metric, and set the percent area open. The percent area open tracks the industry standard pretty well, so if you want 25% open tiles, which is kind of common, then you put in 25. That's the default anyway. If you want 56, change it to 56. There are library items of those two as well, but you can also just set them. You can also have power tiles as well, tiles that are active. I'll show you how to do that too. Ceiling grills and floor cutouts are just drag and drop. You put them in. Cable cutouts can be any size and any percent area open and any location. So we'll show you how to put cable cutouts under racks as well. Blocks we did a little bit the other day. They're fairly straightforward. So I'm going to jump out of a PowerPoint for a moment, and I'm going to go to the interface, and we're going to start to look at some detail inside the modeler itself. So let me pop out of there and let me go to the modeler itself. I have the modeler right here. I want to make sure you can see that. Looks like you can. So here's the CoolSim modeler. It comes up as the way I left it, by the way. It remembers how you left it. So I am in right now full screen mode. I can change that mode up here using split screen or full screen. I'm in perspective. You remembered that from the last time I used the software. So let me first open a couple of models. and show what examples we have here. So let me go to sample cases. Let me go to racks. I made a few examples. These were shared with you. And I'll bring in some active chimneys. Now, this is in no particular order am I doing this, am I loading this, so we'll just go ahead down the list and start looking at different ones and see what they say. So let me first bring in a rack here. Once we load this, I'll drag in a rack and I'll show you around the rack a little bit. And let me hide a few things. Now this design was done, and what we're doing here is we're modeling active chimneys. Now there is a certain kind of rack that has an active chimney on it, and it is popular in the market. So let me hide this baffle right here. By the way, you can right mouse click things to hide them. And you see that what we've done in this design is put PDUs on top of these racks. You see, that's really a PDU. But the way we set it up is to allow air to pass through that thing at fairly low wattage. So now normally in a PDU, if you set this thing, and let's use kW for a moment, if you set this thing for 1 kW, it's going to produce 156 CFM roughly of air. Now that's generally what's required to handle a 20-degree delta across those units. But if you're modeling it as a fan, then those numbers aren't quite right. It produces a lot more air for the wattage. So what you can do, and what we've allowed you to do, if you want to use it as a fan, you can set it for, let's say it's a 500 watt fan, but it's producing, let's say, 4,000 CFM of air. So we allow you to override the air amount to set it up as a fan. Okay? And that the other thing about the PDU is you can punch it through another object. As long as it sticks through, the thing about CoolSim is as long as the inlets and outlets are visible, as long as they're not blocked, they'll work. And you see, I can see that outlet, just barely, but I can see it. And it's poking through, in this case, a baffle, I believe. Yep. And the baffle's probably set to not leak. So over here onto airflow, that's switched off. So it's a non-leaking baffle on top. And what the user has done here, this could have been me, I don't remember, is built these racks inside. So again, let me back up. Normally a rack comes in like this. And it might be easier here if I just start a new one. So let me drag in a rack. So here's a rack, and you see it comes as a rack row. Now the assumptions about this rack row are that there is an inlet and an outlet on each side. So I have an inlet on this side and an outlet on the other side. Airflow direction is indicated by arrow. By the way, number 0 is always a little different color than the others. You see that green, that light green? That means it's the first one in the row. Because once you start rotating these things around, it gets a little dicey trying to figure out which one's which. That color is a little different. We did that on purpose. Now, this is a fairly good representation, first pass representation. I can set it up for average heat load. First of all, I can set it up for different kinds of devices. So it's a front to top, front rear to top. I mentioned this to you earlier. It will change the arrow direction. So now it's a front to top device, because it's coming in the front and going out the top. When you do this, it is ideal. It takes all the air from the front and puts it out the top. That's an ideal rack. It's an ideal rack in all cases. Even here, I'm taking all the air from the front and putting it out the back. There's no rack rail leakage, and the heat load is uniformly distributed across it when I use this method, heat load per rack. Now, this one right now is assuming there's 5 racks in the row. They're all 4 kW each. If I want to change the load so that it's different for each one, I can either make individual racks by cranking this down to a quantity of 1 and then duplicating them. Or if they're all the same size, I can use this individual rack spec feature right here. This does 2 things for me. One, even if I'm just doing average watts per rack, it allows me to very quickly just go across the spreadsheet style of interface and set them to whatever I want. So what I've done right there is change the watts per rack by just entering a value. I can also change the assumed delta T to be whatever I want as well here, just by changing it. So now I've got average watts per rack still, but the amount per rack is different for each one of them. And that's one level of granularity. That's not a bad one for getting started. The other thing I can do is change the position. It doesn't have to sit on the floor. It can come up off the floor a little bit if you want. Right now it's assumed to be perfectly sitting on the floor, no gap at all. And that's not always the case, as you know. These things do have feet on them, and unless people have blanked underneath them, then a more realistic representation would be to have this thing up off the floor 3 inches. But remember, when you do these things, you're increasing the density of the design. In particular, you're, I don't know why I've got 2 there. In particular, you're going to increase the mesh. The mesh is going to go up now because I'm going to mesh down to 3 inches. CoolSim will mesh down to 1/4 of an inch, fraction of an inch if you make it. But remember, I've just increased the density of the mesh because now my minimum mesh threshold is going to be at least 3 inches, probably less because I need 2 cells in there to make it work. So it's probably going to be 1.5 inches. And that drives up the mesh count, drives up the solve time, and drives up the complexity. But you can do it. Now the next level of detail is, okay, now I may want to get into this rack and do something to the racks themselves with respect to redistributing the heat load. So let me go back there for a minute and I'll go into specification. I'm going to go individual spec. I'm going to open up that same editor. But this time I'm going to say, well, yeah, it's 4 kW, but it's not uniformly distributed. It's really got a server sitting here. It's 8 U's, and this server is, let's say, it's got 3 of the 4 kW sitting right there. And then down below, near the bottom, by the way, this is as if you're looking at the front of the rack. And I know the numbering is upside down. 48 is actually at the top, but this was a user interface constraint that we ran into, so we do it this way. You should be able to work it out. So down here at the bottom, I'm going to put another one. This one's really 1 kW. What this interface also allows you to do is define what we call gaps or holes in the system. So here I can put a 4U gap and say okay. Okay, so now when I close this, it's going to have a hole in it. So now I've just changed the detail on this rack to be 2 servers. It's no longer uniformly distributed. I've got 2 servers in it at certain kW load, and I've also got a hole, and that hole will be fully meshed and will be, air will go through it. We can go all the way down to 1U, that's 2.75 inches of resolution. Now I can also, if I want, change the quantity now of this thing and take it down to a 1 rack, and I can make a series of these and put them side by side in any configuration I want and line them up. And remember that we have a clone feature in this software that's very handy. So if I wanted to clone this and I wanted to offset it, say 2 feet, so I wanted 4 copies and I wanted the offset to be 2 feet in the X direction, I could just replicate that rack very easily and make a series of them, just like that. And then I can also take that one and group it and replicate it the same way. So you can make racks pretty quick and lay them out fairly quickly. And you can take the individuals and then put a structure around them to create detail inside the rack. So you can continue to increase the detail here by building specific racks and putting leakage in place that you want. So the level of detail you want to get into here is really all up to you. And I would recommend starting off first with a fairly coarse degree of granularity, assuming average watts per rack, and then beginning to refine the model and crank it up tighter depending on your needs. Remember, a model only needs to be as detailed as necessary and no more. I think Einstein said a model should be as simple as possible and no simpler, I think was the quote. So you want to try to keep it reasonable, but not excessive. And if the room is a mess to begin with and you're trying to show somebody it's a mess, it doesn't take a lot of detail to show them that it's a mess. So let's go back to the model I was showing earlier. This is here what we were modeling as active chimneys. So we took PDUs, set them for the proper flow rate, and just put them in. And put them in a pattern that's indicative. I believe this was a supplier. The company got bought and it's now sold by a company called Geist. And I can't quite remember what these are called. I can't remember the manufacturer of them, but there's a couple. And they'll come in and add these to your cabinets. The assumption here is that the cabinet is fairly sealed. I don't think you'll see any leakage out of the back of this rack row. The geometry is probably, yeah, in this case it's a block. So, there's no air leakage anywhere. The way that racks work is, again, as long as the front is popping through the block or the baffle, it'll run. So here, I'm just going to grab this and pull it. You see me pulling it through. As long as that front is poking through, then it's going to be fine. Now, in this case, it looks like I put the specific, or whoever did it, put the specific detail around it. You don't need to do that. It'll actually slice through just like that, as long as the inlet and outlet are there and showing. So you can build them like this, and you can set your rack rail leakage to whatever you want using baffles. Baffles allow leakage, so let's see what the rack rail leakage here was at 5%. You can also get into the detail of this individual rack. This is, again, assuming that the flow is, the heat load is uniformly distributed. You don't have to do that. You can say, okay, I want in this particular rack, the way that it's really set up, whoops, wrong GUI, sorry. I'm dragging from my other monitor. So what's really going on here is that there's a server that's sitting right there, and that server is 2 kilowatts or 3 kilowatts. And by the way, there's also a gap right there that I need to fix at some point, but it's not there yet. And so you can set the detail up however you want for each one of these. And then you can replicate them or go around and change each one. The cloning feature works really fast to lay these out. Remember that even once I'm done with the whole structure, I can group it. So let me just put this into top view, and I can use my control and my left mouse and draw a rubber band around this whole thing. And there's the tree that shows you everything in there, which you can, by the way, edit individually. And I can group this whole thing. So now it's a group, and I can move it around as a group, and I can also clone it as a group. So if I get this set up the way I want it, and there's uniformity in their distribution, you know, their symmetry, then I can clone it. But this is one way to model active chimneys. It works fine. In fact, we have some results here. Let's take a look at our results. I don't always have results on these, and you can see what's going on here. There's my hot air coming out. I'm looking at path lines of return. There's the hot air. This is run with an older version of CoolSim 4.4, it looks like, so this window isn't as big. But there's the hot air coming out of those chimneys. It's being pulled because I suspect this is running hot enough or hard enough to do what it's supposed to do, and pulling the air up out of those chimneys and driving it up into the ceiling, which is pretty realistic of how those things work. Now, I think, have rack rail leakage. It doesn't look like any of them are leaking based on this particular design. So that's how that works. I don't think there's anything else here of particular significance for us to look at. We could look at air coming from the cooling units. But all right, so let's go look at another design. Again, if you have any questions as we go, please ask them. Is there a possibility to simulate a load bank where a new data center where they have some load banks while they fill up the racks? Well, I don't know how the heat flows in a load bank. I don't have familiarity with a load bank, but fundamentally these are just loads. So you could take a set of racks and set them up in the same geometric configuration as a load bank. I'm assuming a load bank has got a fan on it. You'd have to know the flow rate. And yeah, you could model them as load banks. There's no issue. That was a question that just came in. You would just need to know the geometry of the load bank and the flow rate of the load bank, what the air is going across it, and set them up as racks, I would guess. Set the geometry to be whatever the geometry of the load bank is. That was a question that just came in. So here's, now, one of the things we're assuming here is that the ceiling is perfect. I mean, the thing about CFD is it assumes it's perfect unless you tell it otherwise. So in these base designs that I'm doing, we're assuming the floor is perfect and the ceiling is perfect and everything's perfect. There's no leakage in this floor. The only stuff coming out of the flow is coming out of the floor is these tiles. There is in this particular design a cable cutout. So unless you explicitly tell it that something's leaking, nothing leaks. Now, people will often say, well, you know, the ceiling is a leaky thing because, as it turns out, the ceilings aren't really engineered. They're often just drop ceilings. So in this model, I'm assuming that we've got a leaky ceiling. So how do we do that? Well, the way you do it is put a baffle in as a ceiling. So this is just a baffle. So remember, the baffle object is right here. It comes in like that. When you double-click it to edit it, you get the opportunity to, by the way, room means slab to slab. We covered this last time. Plenum means it's in the ceiling plenum, and general means you can do anything. So we're going to make it general. And I'm going to flip the plane to be the XZ plane, like that. And then I just make it the dimension of the room and set it up in the air. That's how I created this guy at the top. Now, if we look at this guy at the top, he's acting as the ceiling, and guess what? It's leaking at 15%. Now, percentages are a tough thing because it's a function of size, right? In other words, 15% of something very big is different in terms of leakage than something that's 15% of something very small. So percentages aren't wonderful, but they do work. So in this case, we assumed there was 15% leakage in the ceiling, and then I poked the crack unit, made it tall enough so that the outlet stuck through, or the return in this case, stuck through the ceiling, which means that's fine, it'll work. The crack is sitting on the floor, which means it's going to blow air through the floor supply plenum. And then over here for rack detail, what we did is just use a rack row, it looks like. I think this is just a rack row, yeah, and put it inside a set of blocks. So are these blocks or are these baffles? They're baffles. And you can create a set of blocks or baffles, and as long as the inlets pop through, this thing's going to work because the CoolSim has a constraint that you can't block the inlet and outlet. If we make these transparent, nearly hide baffles, you'll see that they're sitting in there and then have these active chimneys that are poking down through. You can see again, these are PDU objects. They're probably set to allow air to come through them at a high rate. Yep, 1 kilowatt, 1500 CFM. So that's a factor of 10 more than normal, right? So these are acting as fans, but they are producing a little heat, which is realistic. And they're sucking the hot air out of the contained area, and up into the ceiling. And there's a cable cutout. So let's go take a look at the results of this, and I think you'll find that, let's first take a look at the rack inlets and see if we have any variation. And we do. We have some variation on the rack inlet. Let's take a look at path lines from racks, and there's the path lines. Looks like most of it is going up into the ceiling just the way it should. It's behaving itself. So there is a little leakage in that ceiling, and this particular design, it holds up okay. So that's one approach to doing detailed racks. There are many others. Often I get asked about communication servers. That is to say that not all of these devices are all pointing in the same direction all at once. So you can just change the direction of the air, and the way you do it in CoolSim is you, well, this is actually a model here. This was a customer's model, and the way they did it in this particular model is they just oriented the rack in the other direction. So these are communication servers. They're blowing side to side. So they made an individual rack, changed the width and height dimension, and have it blowing. Just rotated it 90 degrees. There are other methods. You can stack them as well. So let's take a look at a communication server here. Side flow server is probably right here. So you can also, within one rack, you can set them up so that they're blowing both front to back and side to side. I don't know why this one's called that, because it's, let's take a look at what we have going on inside of this one. This is another approach. I think this one has a, let's nearly hide, take a look. So this one's blowing side to side inside of a cabinet, and chances are the front door is set to open at a certain percent open. So the front door is opened at 85%, and it's in there blowing side to side. So you can do it that way. That's one method. Let's see what else we have here. Racks with communication servers in them. So the other way to do it is to stack them. Stack them up so that the servers are pointing in different directions. So this one was done. Let me ungroup this, and you'll see how this one was done. So there's one at the top. That's a front-to-back server. And then underneath it is a side-to-side server. Now, the way to do that fairly easily, again, is to pull a rack in. Let's just take a standard rack row, and let's take it down to one for a moment. One rack. Now, you can make these any height you want. So for the one on the top, we may have made, and by the way, it's quite handy because it's in use. You can switch the units to use. So let's say you have a 4U server, and it's starting at a U slot of, it's starting in the 26th slot. So just use U's and set them up that way, and keep going. And then, you want to put one the other direction, so you do it again. Maybe we take this one, we rotate it 90 degrees. This could be the communication server. So we want to just rotate it. Change the orientation so that it's 2 feet in this direction and it's 3.5 feet in this direction. So there's my sideward server. And now I just need to orient it in the correct position so it sits on top of this one. So this one, I can't quite remember what we did. In terms of view, its height was 4 and it started at 25. So I want this one to start at 30. So I just edit this one, and I want the start Y position to be, to be 30. Yep, 30. And then I just drag it over. And by the way, you may want to change its color. Color is under general, just so that it looks a little bit different. And then you line that up on top of this one. And then you make a group of them, like I have here, and then you replicate them. So here's the group. Once you have them stacked, then you just group it. Group it by drawing a rubber band around it. So again, the best way to group is probably top view. So you take your control key and your left mouse key and you say everything inside that box I want to be, it's already grouped. I want it in a group. And then you can clone your groups with offset to make more of them, and then you can build a box around it if you want, and then you can save the entire assembly off in your library, or you can export it for use later, etc. So let's just see if this has some results. Let's see how they worked. First of all, your rack inlets are going to be unhappy because you've got rack inlets on the side of those comm servers right now, you see? And of course it's unhappy because it's not getting any air. And then you've got the other fronts here. And in terms of path lines, they're just going to go everywhere because that's how they are. So you can model communication servers in CoolSims running sideways using that method. All right, so let's see what else we have here. Detailed racks, again, I'll just show you different variations of detailed racks. We'll just go through them fairly quickly to show you these. the question came in, why build a rack in a box? It's not a rack in a box. What I'm really doing is modeling the server themselves. Yeah. Oh, closed rack, non-vented. They are vented. So the question is, why do a closed rack with no vents? They are vented. It's just that the back of it, in the case I was showing earlier, was set to leak. So if you look at this baffle on the back, it's not leaking. It's shut off. But I could turn that on and set a percent area open, and it would model the effect of a perforated back panel. So these baffles are handy because you can use them in a variety of ways. You can use them as a sealed entity where they don't leak at all by shutting that off. You can also use them as a perforated enclosure, like a front door or a rear door that's passive by turning this on and setting it to a high percent area open. So this is an example of a design. This was done this is done with passive chimneys, and I used our duct object to do this. So again, these are different kinds of servers. I think this one's probably pointing the other direction, so these are stacked. I made a group of them and then replicated them. So these are all sitting there. There's blanking panels between it. This is rack rail, I think. Yeah, I've defined this as rack rail. By the way, all of these objects have names. The default name is, of course, baffle 1, baffle 2, but you can rename them so that when your output report comes out, you can see what is here and there, and it helps you a little bit. So here the airflow is set on these rack rails to leak at 35%. I probably did that intentionally because I wanted to show the effect of passive chimneys. What happens in a passive chimney design, this is, by the way, just a stack. Now what I've got here, let me ungroup this so we can pull it apart. This is a fluid block. It's what we call a duct. In Fluent we call it a fluid block, and it's just a block. It's just a duct. Remember, you do have to put a diffuser on the top and bottom because a fluid block by itself won't pass any medium because it doesn't know what you want it to, where you want it to go in and out. So this is our little duct designer. Little duct designer toolkit comes up, and I have the duct, and then you see I have a diffuser at the top set at 100 and a diffuser at the bottom. I get the height where I want it, and then I put it in my poke it through. Remember, it's got to go through so that diffuser can be seen on the other side. So if I hide my blocks, you can see what's going on in there. So there's my little chimney coming down with the diffuser on the bottom, and in this case the servers are different lengths because that's more realistic as well, because they are different lengths. And you see the airflow direction is not always the same because I think this guy right here is a comm server and his airflow direction is sideways. And yeah, so that's a fairly detailed representative of a rack. And again, you can save these structures off as groups. So once I group something, I can right mouse click it and I can add it to my library system, or I can export it and read it in later. And so you only have to do these things once, and then you can save them off for use again later, put them in other models. You don't have to recreate them each time. And with the cloning feature, once you get one laid out, laying out a bunch more is easy. So let's go to the output. This is done in CoolSim 4.5. I can tell because it's got this new output feature. And let's take a look at some path lines from racks so we can see what's going on. And what's going on is lots of leakage around the front. Now, I did set the rack rails to leak kind of high, 35%. But you can see the effect here of a passive chimney. You see what happens is, and by the way, in 4.5 we also have this nice little editor that allows me to shut off surfaces. You use the E button. E is for edit. Once you see these 3D views, and you're able to do things like shut off blocks like that. And shut off generally the room as well, makes it a little cleaner like that. So there's what's going on inside that rack, and you know, this is quite realistic. What's happening here is this bottom server is being blocked by the one above it. So as air comes out of the bottom server, it bangs into this guy. By the way, this guy's blowing air pretty hard, I think sideways. I think that's one of the ones that's sideways. And so you get a lot of mixed up things going on, a lot of pressure variation going on, and because there's no active chimney here, It's just dumping out the top, so there's some flow impedance in this direction, and guess where the air therefore goes? To the front. So passive chimneys can be challenging, particularly if you have, let me flip this around and turn off perspective. If you have different length of servers, which is not uncommon, you can run into this problem. Furthermore, if you have a high-density server sitting here that's got a big fan in it, because high-density servers do, it'll create an air curtain here, and these servers below can't get their air by this one, and that causes problems too. So I have seen inside of racks, particularly passive racks, with chimneys, this problem. Now, having a ceiling plenum in place where this chimney is hooked up to the ceiling plenum helps a whole lot, because it creates a low pressure in the ceiling to pull that back. But even then, you run into problems with a leaking ceiling. If the ceiling it's not a very well engineered ceiling, you'll run into the same problem, because by the time you get from the crack over to these racks, the pressure in the ceiling has gone from negative to positive, and you've got this same problem again. So that's one I wanted to show you. Let's see what else we have here. We're running out of time, as always. Communication servers, rear door heat exchangers, detail racks, passive chimneys. I've done those. So I often get asked about rear door heat exchangers, and that's not really a rack thing per se, but people want to do that as well anyway, of course. And the answer is yes, you can do rear door heat exchangers. All I do there is use the in-row unit and size it to be the same size as you want for the output. Now, this one was done, it looks like, in 4.4. So here we have a series of servers here, and they have rear door heat exchangers on them. So all these are, if we take this apart, this is just an in-row unit. So all I did was take this crack unit right here, which because it's a non-raised floor data center, when you drag in the default unit, it defaults to an in-row. Take your in-row unit and just make it the size of a rear door heat exchanger, and then put it on the back of your system. You can do this however you want. The simplest model for doing this is to just have a rack row and to put these on the back of the rack row. So let me flip this back up to the top. So the easiest thing to do is to take one of these units and just put them here like this, and then use your clone button to create, 4 more of them. So if I were to clone here, and I were to use an offset of 2 in the X direction, and I want 4 of them, then I could just create 4, just like that. Very easy. And now you have independent control over each one of those as well, and you can set them up however you want. You can set them up for delta T, or you can set them up for supply temp, or whatever you want. Now there is going to be a little leakage between here and there. That's, by the way, normal, and it is realistic. But what I've done here is gotten into a little more detail. Here it looks like we were modeling, and let me just go to the top view here so we can see this a little cleaner. So here it looks like I wasn't running these rails all the way back. We were doing some studies about N+1 on these devices, because if this block right here comes all the way to the back and you lose one of these cooling units, you're in trouble. Furthermore, you have to be careful in these designs of leakage in the rails of these kind of designs, and I think we put rail leakage in here too. So there's rack rails. I labeled it, and let's see what our rails are leaking at. Yeah, I set them at 95%. I think I was trying to make a point there. And the servers are just poking through just like before. Now then we started to do N+1. Yeah, what I was doing here is seeing what happens if one of those units goes down, because one of my customers wanted to know this. What happens if a rear door heat exchanger goes down? So the way we did it is to take a look at the case where they fail, and you see they're starting to wrap. These are path lines from racks. Whoops, let me get this around, and let me use the E key to shut off blocks so that we can see inside there. So let me just turn off the room again and turn off the blocks again. And you see what's going on is the air is going around. Some of it's going through the the cooling unit, but there's also some going around those rack rails to the front. So the point here is that you need to understand the failure mode conditions of these kinds of devices and what happens if one fails. As you can see in this design, what we did, again, let me use keystrokes. I'm going to do Y and then N. In this design, what we did is we allowed the air to go from the one that hasn't failed over to some of the others. In other words, the unit behind here, I think, has failed right there. So its hot air can go over and pass through this one because we don't have a block going all the way back. In reality, they do. There's usually one of these per cabinet, and there's no opportunity for one to cover for the other. And so it wraps. But yeah, rear door heat exchanger is not a problem. We can model those as well. Let's see what else we have here before we start to move on. Simple in-row. In-row is not an issue. Triad tile server modeling. I've already shown you how to do that. Rear door heat exchanger, communication servers. Sometimes you get some strange designs. Someone asked about this earlier, so I'll bring it up. This is a plexiglass cabinet. And this one has, sometimes you see these designs. This one is a sealed system. I think it's open in the back. Again, to tell, you have to really take a look at what's back there. I just double-clicked on the back. So the back is open at 90%. But the way this one gets fed is through a cable cutout in the floor. So let me just review cable cutouts for a moment. They are just, you know, standard cutouts. They're up here, cable cutout. They sit on the floor. They have a percent area open. If you want to model holes in the floor under your cabinets accurately, one way to do it, the most common way to do it these days, is to put this in. And then let's say that your cable cutout is not a foot by a foot, but let's say it's 3 inches, so it's 0.25 by 0.25. Or that's not unusual to have it 3 inches. You can also switch to inches. That's pretty small. That's going to cause the mesher to go a little crazy, but that's okay. You can have one of those, and let's say you wanted to put a rack row here and let it leak. So, and they generally run to the back, so they're usually in the back of the rack row. And again, I can clone this. So once I've got one set, let's say I wanted 5 of them. I wanted it offset by 2 feet. And so I could set up, what did I do? It's going to go out of the room. Distance along. Oh, sorry, not 5 feet, 2 feet. And put a series of those in. Now I can bring my rack in. Where's my rack? And set it right like this. Okay, I guess I had one too many. Now it's sitting on the floor at the moment, and that won't work because I'm blocking the outlet. So what I can do to this rack row is if I want to model that leakage, I can set this up off the floor by a little bit. So I can set this up by, let's say, 4 inches. And that's a fairly realistic representation of how things work. So there's my, my rack row. Now I've actually got it on the wrong side. It should have been over here, but you get the idea. The holes are to the back. And you can set it up underneath as well. Get them lined up. Usually the top is the way to do it. You can run them like that. You can run them any way you want. You run them like that, or you can run them like that. So let's see if this has any results. No, it doesn't. Okay, so let's move on. And I think I've done most of these server level detail, server level modeling. So I think you get the idea. I'll just load this last one to see. This one is the same as before. I don't think there's anything unique about this. Again, it's effectively what I'm doing here is modeling the servers themselves, because I make this thing 19 inches wide. So the outer dimension of the cabinet is still 24. But internally, the width of this, if you take a look at the width, start X, I'm talking about rack width. And X is 19 inches. And that's the size of a server. And then the the rest of the cabinet is 24 inches. And so you can get the leakage in the rack rails in there. So let's just open a new one now. I want to make sure I'm getting to my agenda and covering all the topics I wanted to cover. So I'm just going to go back here and so we've done modeling internal leakage. We've done communication servers. We've talked about PDUs and PDUs as fans. We've talked about cable cutouts. So in the time remaining, let me go to tiles, and we'll start to look at some objects as well. Perforated tiles are fairly simple. You just drag them in and drop them. Again, they come in quantities. We tend to work in tile rows. So you can have a quantity of them. You can rotate them. You can set the percent area open on them. They default to 25%. This is kind of a generic tile. You can also put in power tiles. This is like the adaptive cool tile. You can put in a tile assist, but you need to tell it which rack to look at, and there's no rack there right now. But you can put in power assist as well. So let me just put a rack in here. Now these tiles are being modeled as porous media. So it's a porous surface and it allows the air to come through. Modeling the specific geometry detail of a tile in a data center is the detail is too fine. The model would get too big if we try to model the geometry specifically. So we approximate it through a porous media membrane. And that works fairly well, except in the case where you're trying to model something like a triad tile. Triad tile has got fins on the bottom of it. And so it is like a porous media, at least you can model it as one, but the benefit of it is it has some fins under the floor that direct the airflow. Now in CoolSim we have the ability to rotate a baffle, so you can actually make a fin out of these baffle devices. The first thing you have to do, remember they come in the room, which means it's bottom to top and you can't adjust its height. So you have to make them general, and then you have to set the height to be whatever you want. Generally I set them to be 3 inches, and then you can set them at an angle and put them under the floor. So here I'm going to just grab the way you do angles in a baffle is you point at the edge you want to be the point of rotation, the axis of rotation, and you right mouse click it and it turns it into a pivot point and you can angle it. So you can do this on diffusers and you can do it on floor tiles. And I've built a couple of these already and I'll bring them in. So with CoolSim you can save your objects. They come in as object files, so I can do import object. And let's go to a few of my objects here and see what I have. Sample cases, so rack examples. CoolSim objects, and under objects I've got tile objects. Let's bring in a triad tile. This is an assembly. There it is right there. Because it's an assembly or a group, I can move it anywhere I want. And you can see the way that this works is that underneath the floor there are angled baffles. And this actually works very well, and it shows a big difference. And this is modeling a triad tile. Triad is one of the suppliers. Triad's the only one with fins under the floor. So this is how you model it, and it has a fairly pronounced effect. Now it is oriented in a certain direction. You see those fins are oriented in this direction. To rotate them, you'd need to build another one with the angles at the other side. So I created another one and I oriented it the other way. So there's one oriented the other way. And if you wanted to change the fin direction, which would effectively be moving this 360 around in a circle, so the fins go the other way, you could simply just go to the individual fin, delete these three, change this angle, and then clone it with an offset to recreate it. So you can do them either way, and those work quite well. You got to be careful where you put them. If you put them too close to the floor, it causes a problem because, again, you're crowding that outlet. So I tend to put these down about 2 inches, 3 inches into the floor. If you need any help with those, let me know. and we'll help you. So that's the end of it. Now, let me just make sure that I've covered everything. I'm going to bring my PowerPoint back over and make sure that I've covered everything. So model IT racks, sorry. Server detail, we reviewed that. PDUs, perforated tiles, cable cutouts. Blocks are fairly straightforward. Baffles I mentioned. So I guess the point is there's a lot of different kinds of racks. It does depend what kind of level of detail you want to get into. I would recommend average watts per rack, that each rack has its own level of wattage. Leave them on the floor at first until you get the model run and see what's going on, see where your big airflows are, see what the balance in the room is, things like that. You can model both passive and active cabinets. You can generally build them as structures. Again, we do have some of those. I did create a shared area for you all. If you were not able to get at that, please let me know and I can add you to the shared area where these models are right now for this class. Cable cutouts can be modeled under racks. I showed you that. Don't be afraid to use the clone capability. You can clone any group of objects. So once you get the cable cutout under the rack the way you want it, you can group the cable cutout with the cabinet, with the rack, and clone them both as a group. You can do detailed modeling for things like triad using assemblies and angled baffles. I showed you that. Floor leakage. Let me just quickly show you about floor leakage before we go. There is a parameter in CoolSim in the new release, and it's a floor leakage parameter. It's under the room tab, and it's under specifications. It's called tile leakage. This will allow you to set up certain leakage through the floor tiles, only the floor tiles. We don't do ceilings yet. But you can, again, it's a percentage or a volumetric per unit area. It is uniform, and that can be okay or can be problematic depending on your situation. If you want to be more specific than that, one of the things I have seen people do is take a cable cutout and put it over a fairly large region. Say you've got a mess over in this region and it's got all kinds of perforation in it. You can just set this thing to be fairly large and put leakage over there. So here I'm saying that there's a section of this room over here that's a mess and it's leaking pretty badly. So I'm going to set this leakage over here at 20% and leave it there. That'll make that section of the room leak. Now you need to be careful. You can't put anything on top of that that's going to block this. So if you've got a rack and you bring it over here, this will fail because you've blocked an inlet or outlet, and CoolSim's sensitive to that. But you could bring something over here and just get it up off the floor a little bit. So you move it up off the floor 4 inches and then it will behave itself and it will run fine. So question was, how did I model the plexiglass baffle? Let's go back to that. Let's see if that was an object or a project. I think that was a sample case. The plexiglass. So under sample cases, under racks, I had that plexiglass. There's the plexiglass. Now in this case, what the customer had here was they were sealed on the front and the sides. The back was open. Air was coming from the bottom. So again, all I did in this design was the front is, I think, a baffle, no leakage. Okay? And they're sitting on the floor. There's nothing underneath this except the cable cutout itself. The air is coming up through that cable cutout in the floor. The walls are sealed, and the air in this case was going out the back, so I believe on the back here we had airflow at 90%. So that's how I modeled, or they modeled, or somebody modeled. I can't remember if I did it or not. So a couple more questions coming in I'll try to do. I've heard that the raised floor leakage of 2%, never been able to find out what 2% is of. Do you know anything about that? Good question, Kurt. Yeah, the percentages are problematic. It's easy to say 2%, but 2% of what is a fair question. Is it 2% of the area is leaking, or is it 2% of the total flow is leaking? We've found that in general these things do leak. Furthermore, it's very hard to make good measurements in a data center using instrumentation. Bolometers generally read off by 30% because as soon as you put a bolometer on top of a perforated tile, it affects the flow because the pressure is so low that it's difficult to capture it. So they tend to read off. They're off generally by 30%. They're generally underpredicting what's coming out of the floor. So I agree with you. It's not clear. When the manufacturer says, I've got 2% leakage, we always have a question about what that means. Same thing with containment. They'll say, well, containment leaks at 5%. Well, is it 5% of the total surface area? Because if it is, that's a lot. Or is it 5% of exactly what? So there haven't been any good studies to know exactly where the leakage is. What I tend to try to do is be explicit about it. I tend to try to say, okay, well, in general, this thing's in pretty good shape, and I may turn on leakage a little bit for the floor just to be safe, but I generally don't. And then I try to explicitly put the leakage in where it belongs using things like cable cutouts, and try to be explicit about it. So next question, what is the difference between 20% leakage on a cable cutout and 20% open perf tile? Nothing. They're both porous media and they're leaking. So it just has to do with the area, to be honest. So here's a perforated tile. It's 2 by 2. If you turn that on for 25% leakage, because the surface area is greater, you're going to have more total flow coming through there than you would this one at the same leakage because it's geometrically smaller. But on the back end, we treat them the same. They're porous media. That's how we treat them. So I think that covers most of the questions that have been asked. I don't know if any of you want to try to speak or just type it in. I think, let me just see if anybody's got their hand up. No? Some questions, no hands. Okay. Well, I want to thank you for your time today. I did record this session, so it will be available on our website. The session from Monday is already on our website, and it is under webinars. So let me just show you where that is. If I go to our website and I go to Webinar Archives, you will see under Webinar Archives the design optimization, or did I put it under, here it is, right there, webinars, modeling raised floor data centers. So I'll record this one today. I have recorded it and process it and put it there too, in case you'd like to review it. I'd like to thank you for attending. Those of you who are my customers, I want to thank you for being my customers. I appreciate it. In the next session, we're going to be talking about analyzing results and taking a look at failure mode situations and understanding where they go. So let me just do my day 3 outline here. Setting it up, running it, analyzing results, using crack parameter analysis, which is very handy, and then how do you use the results? How do you present it? And I think there's a lot of opportunity there for you to illustrate what you're doing using the tool to others, and troubleshooting. We'll do this Friday at 9 o'clock, and again, I'll record it in case you have a conflict. You'll be able to watch it offline. I want to thank you for attending. I appreciate it. Have a good day.